Okay, so the first stage of cleanup has been done. As you can see, I haven't done anything to the base yet. I don't have a tray the right size to put that in to give it a good soak in vinegar, but I've got some cheap foil baking trays coming from the internet, so hopefully that'll get that sorted in the next few days. But all the brass work has been cleaned up. I was able to straighten out the prop shaft tube, tunnel, whatever you want to call it. That cleaned up quite nicely. I actually just used a bit of degreaser on the engine frame, and that cleaned up really well. So everything else just been basically wire wheeled, really. I know I keep banging on about vinegar and how good it is for cleaning stuff up, but it really does do the job. And it's so, in the UK anyway, white vinegar is so cheap. So the boiler and the firebox have been in the white vinegar bath just overnight. That's literally overnight. Every single trace of rust on that firebox has gone, and you saw how rusty that was before it went in. Now all I've done is given a very light brushing over with a brass wire brush. Same with the boiler. You know, the bottom of that boiler was absolutely caked in soot and shit, and it's just come off, and it really has cleaned it up really well. Now I'm not going to do any more cleaning work on it because I've got things to do, like cap off the steam feed there, and I've got to take the chimney off. So until I've done that, I won't bother doing any further cleaning on it. But yes, it's all coming along really nicely. I'm quite pleased with the way it's worked out. I've managed to straighten out the copper pipes. I may well simply replace the exhaust pipe because this particular one was really badly kinked and squashed. And I mean, it's strained out okay, but it really is. It's been butchered, and in its life, it's had a very hard life. So I may well just replace it. It's only a bit of 1/8 copper pipe, so tube. I've got plenty of that. So yeah. So next stage is I've got to make that adapter up for the boiler, which will be a little bit of lathe work. And basically, from what I will do next is work on the boiler to do those things that I said. So that's what's going to get done next. So some progress on the Mamod ME1 marine engine. My fake ME1 boiler is now finished. Turned out okay in the end. The chimney was only riveted on, as they normally are with these little Mamod chimneys, and this is very soft brass. I was actually just able to prise it off and leave the rivet in there. So hopefully that will still be sealed. Same with the fitting. This was the fitting, the steam fitting, which was in there. And yeah, I basically pulled that out. I put it in the vise, twisted it, and I think it was just pressed in. So that came out nice and easily. I made a little brass top hat plug, which I've soldered in place to blank off that steam feed. And I've made a turret for where the safety valve sits. I'll turn it around so you can see where the hole in the side there for the steam pipe. And the safety valve just basically screws into the top like that. I was also able to get out and paint the firebox with high temperature engine paint. So that's all done. If anyone's interested, the thread on these old Mamod safety valves is 3/8 British Standard Cycle thread, 3/8 by 26 TPI. I did already have a die because I've made safety valves for Mamods before, but I didn't have the tap, but the taps are readily available. As you can also see, I've cleaned all the paint off of the base. I did not use a vinegar bath because the trays that I ordered on eBay still haven't turned up, and I got frustrated waiting for them, so I actually did that on the wire wheel. It was hard work, but it cleaned up okay. Now I've got to wait for it to stop raining so I can get outside and etch prime it and then put the top coat on. So the next job is to make one of these. Now this is going to be a series of tips involved in making this relatively simple shroud. And I'm sure that most of you guys out there that have got workshops probably know all of this stuff already, but I'm going to say it anyway, just in case there are a few people that don't know this. First off, stainless steel in the UK, certainly even thin sheet stainless steel, is very expensive. This was a tip that my Fid boy gave me probably a couple of years ago now, and that is use stainless steel toilet brush holders. Yep, that's right. Toilet brush holders. Now you can buy stainless steel toilet brush holders relatively cheaply. I think the one I used for the stainless steel sheet that I'm going to use to make one of these. I think I paid £7 for it. It's about a year or so ago, but I did check online, and you can still pick them up for around about £8 in the UK, which is much cheaper than buying the stainless steel sheet from eBay. And there is my bit of stainless steel sheet, which started life as a toilet brush holder. Very nice stainless steel sheet it is too. Now, obviously you've got to flatten it out, cut the bottom off because it's a cylinder to start with. If you've got a roller, then flattening it out is really no problem. But you can do it manually, and it's not completely flat, but it's perfectly good enough for what I want for the shroud that goes around the boiler. Now, I've already marked it out. These are the fold lines. These are the 2 lines for the vent holes, and this is the center line. I've actually already drilled the hole for the steam turret, and I've drilled 2 of the fixing holes. And right, so let's get on to tip number 2. Right, tip number 2. We have 6 holes on this side and 6 holes on this side. They're equidistant from each other. So this is, I can't remember where I read this. It may have been on homemadetools.net. I honestly can't remember. Anyway, this is a real simple, easy method using a digital caliper to work out what the pitch spacing of these holes is. And this is all you do. So you set your caliper to 0, measure the holes. Any one, doesn't matter, they're all the same. And they, bizarrely, they come out to 7mm. Don't ask me why, this is a British engine, but there you go. So you 0 it after you've got your hole diameter, and then you measure the edge to edge on 2 of the holes, like that. Okay. I think it's about 60, yeah, it's about 16, it comes out about 16mm. That is the pitch of the holes. So if you then slide that back, 0 it again, wind this out to 16mm. There we go. Yeah. There we go. Right, so that's what I reckon the pitch was, and if you actually look at it, it's spot on. So that's a real simple, easy way of finding out the pitch of equidistant holes. So for marking out, basically I just measured this shroud off of the ME3. It turns out the first hole at either end is exactly 1 inch away from the end of the cowling, so that's nice and easy, and it's easy enough to measure to work out the distance between them. So starting with, I just used an ordinary pair of calipers to do it. Starting from 1 inch, and then you just go down the line like that, so forth and so on. Mark them up, then center punch them. And this is now ready for drilling, and this is where we get on to tip number 3. Just before we get over to the drill press, want to make a little note here. When you're drilling anything, any metal, it's all important, I banged on about this before, to get the speeds and feeds right. And your little black book here, if you've got one, really useful to this. There's an entire page, there we go, all about speeds and feeds for high-speed steel drill bits. Close in on that. That's got loads of really good information on it, and we need to, we're drilling stainless steel, which is this first column here, and it's a 7mm drill. We go across and it gives us a spindle RPM 543. Now obviously you're not going to be able to get that exact, but you can pretty much, most drill presses, well certainly older ones, will go down to about 400 RPM, so you can get something pretty close to it. Now over on the drill press, and drilling sheet metal is a right pain in the arse. Anyone who's ever done it knows that it's quite difficult in theory to get decent holes in thin sheet metal. Now I've got this clamped down, obviously it's nice and solid, it's all lined up. So what's the secret then? Well, believe it or not, it's that. That's a bit of an old t-shirt I cut up. I saw this tip on Prezzo's, Mark Preslin's YouTube channel, and it's just unbelievably simple, but it works. So what you do is you cut up a piece of material. I use an old t-shirt, okay, like this. You fold it over once and you fold it over again, and you need to make it big enough so that it's bigger than the drill. Now I've already got this lined up on the center point, center mark. Put it under there like that, and you simply drill through the cloth and into the metal. Very important that you go very steady on the press, because you want the drill to cut through the sheet, not punch through it. So we will be going slow. This is set to the slow speed that my drill press runs at. It's about 408 RPM. It's a bit too slow really, but the next speed up is 785, which is too fast. So slow is better than fast on this particular, in this particular instance. So let's give it a go. Right, I'll turn the camera off and we'll take the bit of metal off so you can have a look. So there you go. What it gives you is a very, very nice, clean, perfectly round hole. There will be a little bit of a burr on the back, but you can take that off with a Nuga deburring tool, no problem. But I've found that this works really, really well. There you can see, well, I don't know how well you can see it, but that's the hole that I've already drilled for the steam turret to go through. So yeah, it really does work. The material seems to stop the thin sheet from trying to climb up the drill bit when you're drilling it, and consequently you do get a really, really nice hole. So I'm going to go and do the rest of those. It's going to take a while because I need a bit of cloth for each one, and I've got to reposition it and everything. We'll come back when it's done. Okay, there's the shroud, the boiler shroud finished, and those holes came out really, really well. I mean, this is quite a large one here, and as you can see, they're all perfectly round. There was a little bit of deburring to be done on the underside of the hole, but you know, you just use the Nuga for that, and you know, that comes out pretty damn good. There is no problem with those at all. That method with the bit of cloth, it really, really does work well. So let's get it on there and have a look at it. Okay, I think that gives you a pretty good idea of what it's going to look like. I'm quite pleased with the way it turned out, particularly the holes, obviously. This is a bit larger, the steam turret, than the one on the ME3, but that's because obviously we've got a much bigger safety valve. The diameter safety valve is much bigger, but yeah, it's looking much more like it should do. Now really all I've got to do, all that's left to do, is etch, prime and paint the base and then reassemble it. I think it's all ready to go back together. So yeah, we are definitely getting there.